Alright, 7.7a, we're going to talk about the distance formula. And our distance formula is used to find the distance between 2 points on a coordinate plane. Our distance formula looks like this. D stands for distance, and it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And our x2, x1, y2, y1, those are the same thing. That's the same thing we were doing when we were finding slope, when we labeled our x1, y1, x2, y2 on our points. So if we look at our example down here, if I label my x1, y1, x2, y2, all I need to do to find the distance between these 2 points is plug them into my distance formula. So when I do that, I get D equals square root 3, x2 is 3, minus x1, which is 1, squared, plus y2, which is 7, minus y1, which is 2, squared. And then I can just either plug that whole thing into your calculator, or if you want to simplify it down a little bit, it cuts down on the number of mistakes you might make. I find that to be a little bit easier to do first. So if we simplify this down, we get the square root. I know 3 minus 1 is 2, so I have 2 squared, and 7 minus 2 is 5, 5 squared. 2 squared is 4, and 5 squared is 25, so I have my D equals the square root of 4 plus 25, which is the square root of 29. And now I can plug into my calculator square root of 29, and I get my distance is 5.4. Okay, so if we look at number 2, again I'm going to label x1, y1, x2, y2, and plug them into my formula. Square root, got a negative, or I've got, 5, x2 is 5, minus a negative 3 squared, plus 1 minus 8 squared. 5 minus a negative 3, that's 8, so I've got 8 squared, and 1 minus 8, that's a negative 7. Now that negative 7 is still in my parentheses, so that whole negative 7 is squared. So when I do the distance formula, I should never get negative numbers. It should always be positive. So if you get a negative number, you know you plugged something in incorrectly. So if I have 8 squared, that's 64. And negative 7 squared, with that negative 7 in parentheses, is plus 49. Which is the square root of 64 plus 49. We get 113, and the square root of 113 is approximately 10.6. Okay, number 3, what's the distance between 4, 5 and negative 3, negative 5? Again, I'm just going to label x1, y1, x2, y2, and plug them into my distance formula. x2, we have negative 3 minus 4 squared plus negative 5 minus 5 squared. Negative 3 minus 4 would give me a negative 7. That negative 7 is still in parentheses. And negative 5 minus 5 is negative 10. Negative 7 squared is 49. and negative 10 is 100 squared, or 100. Negative 10 squared is 100. So I get the square root of 149. Now I can plug that into my calculator. Square root of 149 is 12.2. Alright, number 4. This one's asking me to graph the coordinates and then find the length of my segment AC. So let's start by graphing point A. I've got 5, so I'm going to go right 5. 1, 2, 3, 4, 5, and up 1, 2, 3. This is my first point. Then I've got negative 1, 3, so I'll go left 1, up 3. Then left 1, down 2 for C. And then finally, right 5, down 2 for D. I'm going to label my points here. So this was A, B, C, and D. Now it says connect all my points to form my rectangle. What is the length of segment AC? So that is my diagonal right here. So I want to find the distance between point A and point C. So to do that, point A is my first point, x1, y1. Point C is my second point, x2, y2. I can use my distance formula to find the distance between those 2 points. So I'm going to take my x2, which is negative 1, minus my x1, which is 5, squared, plus y2 minus y1 squared. Okay, well, negative 1 minus 5, that's negative 6. And negative 2 minus 3, that's negative 5. I get 36 plus 25, which is 61. And the square root of 61 is approximately 7.8. That is the distance between my 2 points.